If you ask to find the exact value of sine 15 degrees, now 15 degrees is not a special angle, but we know that to find sine 15, we may consider getting 45 minus 30, since this is 15. So if we know by expansion, this becomes sine 35 plus 30 minus sine 30 plus 45. Then we know that this is root 2 over 2, and plus 30 is root 3 over 3 minus sine 30 is half, and the other one is root 3 over 2. So we have root 6 over 4 minus root 2 over 4. Okay. If we go to cos 165, again, there could be two numbers we can add or subtract to get 165. So let's check the number. What is 165? So 165, so that should be a region of 180 minus 52. What is this going to be? I think be sure that the 180 minus 65 is 180 minus 15. Yeah, it's 165. But maybe it will take us much time because the 15 again will require an identity. So let's check. Maybe like banana way. What would be the other way? 120. So I'm thinking for two numbers. Okay, let's see. So we have cos 165. We have two numbers we can add there. Okay, I can't figure them out. So let's go the same way. 180 minus, or maybe we divide it by 2. Let's see. 165 divided by 2. No. Okay, multiplied by 2. 165 by 2. 165 by 2. 3/5. Okay, 3/5. Yeah, you're doing that a bit there. So let's change the identity. Let's use the let's use this one. That will be easier than that. You know, if I have cos of x over 2, it is the root of 1 plus cos x over 2. So we know that cos 65 is like 3/30 divided by 2, which is going to be the root of 1 plus cos 3/30 over 2. But what is cos 330? Cos 330 in the second one, in the fourth one, remember 330 is the same thing as 360 minus 330 will give us 30. And cos 30 we know it's what? It's root 3 over 2. And then I have a 2 here. So I'm going to have a 2. And then we'll have 2 plus 3. Yeah. And then we divide by 2, which is like multiplying down by 2 here. So then it will be 2 plus 3 over 4, which becomes root 2 plus root 3 over 2. Since we know the root of 4 is 2. Is there a question? So root your hand on that.
No, sir, it's okay. I've understood.
Okay, thank you. Okay. That's all. So look at the previous week. I'm now moving to E. So E is sine 11 pi over 12. What is 11 pi over 12? We first convert. It will be 11 multiplied by 180 over 12. So you see, if we divide by 2, this will be 6. 2 here we have a 9. By 2 here, this will be 3. By 2 here, this will be 45. 3 here, 1. 3 there, that's 15. So now we have 11 minus 15. That's 165. So this is like sine 165. So for sine again, we have a similar identity. We have a similar identity. Let me put the identity. So we have sine x over 2 is equal to the root of 1 minus cos x over 2. So again, you can do the same. So write this as sine 330 over 2, which is equal to the root of 1 minus cos 330 over 2. Now I've already found cos 330 will be root 3 over 2. So now the only thing we have which has made the difference is the minus here. So I get a 2 minus 3 over 2. So the secret here is whenever you are given numbers here, the question is, could there be two numbers I can add to get that given number? One, or is there a number that is a special angle which I can divide by 2 to get that number? Or is there a number I can multiply by 2 for it to give me this value? So we have another one, C. C, we have tan of 105. 105 is the same thing as 60 plus 5. And the identity for tan is tan 60 as tan 5 over 1 minus tan 60 tan 5. And what don't you know? We know tan 60, we know tan 5. What is tan 60?
Tan 60 is root 3.
What about tan 5? So we have this, so you can do that too.
That's why many things test the thing that will draw the triangles.
I'm telling you.
So the question in the hand, okay. What's the question? Sentence. Okay. Let's go to question 4 now. Question 4, say 4 squared pi over 8. Now, if you divide 100 by 8, you will discover that this is like 22.5. Now, 22.5 is the same thing as 45 over 2. Okay, so instead of having a root, this thing is squared. So it will just be 1 plus 4 or 5 over 2. There will be no root because it's squared. That will be 1 plus 2 over 2 over 3. 52 plus 2 over 4. Okay? So you do that to almost everything that is there. Let's do this one. We start proving a bit. In fact, cos x minus pi over 2 is actually equal to sin x. Now we know that to pick the left-hand side, expand cos A minus b is cos A cos b plus Sine A, sine B. So we'll have cos x minus pi over 2, which is cos x cos pi over 2 minus then plus sine x sine pi over 2. But you know pi over 2 is 90. So cos 90 is 0. So this something is going to be 0 here. Plus sine 90 is 1. So we have sine x times 1, which is sine x. So all these questions here, the only thing that we are asked to do is to show that you understand how to do the expansion of this. G is sine x minus pi over 2. That is sine x cos pi over 2 minus sine pi over 2 cos x. This is 0 and this is 1. So we'll have minus cos x. Yeah. Let's go to question 8 and solve the equations. The first one, 2 cos x minus 1 is equal to 0. So we're solving for x between 0 and 2 pi. So we have 2 cos x is equal to 1 divided by 2. We are getting cos x is equal to 1 over 2. Then from there, we now look for an angle x that gives us half of cos. Now we know 1 from the first quadrant is the degree. So if it gives us half of cos, then there should be another one, since cos is positive in the first quadrant and in the fourth quadrant. And so there's another angle in the fourth quadrant where cos is equal to half. So what angle is that? It will be 360 minus 60, which is 300. Okay.
So,
Uh-huh.
since the interval is in radians, are we supposed to leave it in degrees or we need to convert it to radians?
It doesn't really matter. You don't lose much, but you can convert to radian.
Thank you.
Okay. What about B? B is cosine x plus x plus cos x is equal to 0. So we fact out the common thing. Cos x will remain cosine x plus 1 equal to 0. So we'll have cos x is 0 or sin x. And here is 0 is giving us Sin x is minus 1 over 2. So here, x is going to be what? Where is cos 0? 90 and 70. And then for sine, you start by going where sine is positive half at 30. Now look for that page in the quadrant where sine is negative. Sine is negative here and there. So in the third quadrant, 30 is 180 plus 30. It gives us 210. In the fourth quadrant, 30 is 360 minus 30. It gives us 330. So we have those. So we have those. We have those angles there for everyone. Okay. Then if we have sine 2x is equal to 2 and 2x. Now we know what sine is. Let's say we have sine 2x is equal to 2 sine 2x over cos 2x. If we cross multiply, we have cos 2x of sine 2x is equal to sine 2x. That is cos 2x sine 2x minus 2 sine 2x is 0. And then factor out sine 2x, then we will have 2x minus 2 is 0. So we have sine 2x is 0 or cos 2x is 2. But now this one is not possible. Remember, sine is only between 1, cos. Can be beyond those numbers. So that means that we only have this one. So x for sine is 0. The other x, so now we're saying 2x is also 180 and 2x is 360. So meaning that x here is 90 and x there is 180. So we can go and pick angles that are outside 360 because when we divide them, we come back to 360. So like 180 plus 360.
Sir,
Hello.
me, I'm not understanding like what you're doing in this question. Like, where are these values coming from? My 2x is equals to 180. What?
Also buying it.
Which value?
This value is for 2x is equals to 180 what? 2x is equals to 360. These values I'm not understanding.
Don't want this.
One. Yeah, bundle. But you remember something like this. Remember something like this. Here we said we have post of sine, post of sine, post of sine, post of sine. So we are looking for the angle that we can put here for us to get 0. Now I know that when x is 0, 2 times 0 is 0, and sine 0 is 0. That's why I put 0 here. Another thing we know is that sine 180 is 0. So it means that the whole 2x, which is an angle, should be equal to 180. But if the whole 2x is 180, then we know that x is equal to 90. Again, sine 360 is 0. So 2x could be equal to 360. But if 2x is 360, then x is 180. Also, sine 540 is also 0. Since 540 is a coterminal angle to 180. But if we divide, since there we have 2x, if we take it to 540, we get x is equal to 7. Another one is sine 720 is also equal to 0. But if we let 2x equal to 720, we get back to 360. And all these angles, all these angles are in the quadrant. They are within the range that we asked for x. Since I thought x should be between 0 and 360. Any questions?
Sir,
Hello.
are you simply saying that we're getting the values of signs that gives us 0 from the angles that we already know?
Yes.
Okay.
Whatever sits as an angle, you pick angle that
Mhm.
no gives you those values, and nothing sits as an angle that gives you.
Okay. Okay.
Okay. Any other questions? Okay, so this session only here. And people will join, and these are more equations.